Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid chlorides, acyl chlorides, are highly reactive acylating agents. When an acyl chloride reacts with a nucleophile, the nucleophile attacks the electrophilic carbonyl carbon and the chloride leaves as the leaving group, nucleophilic acyl substitution. Moving on to the next step. Identify the reactants. Acetyl chloride, CH3C, is equal to OCl, reacts with hydrogen sulfide, H2S. Moving on to the next step. Identify the nucleophile. H2S acts as a nucleophile through its sulfur atom, analogous to how H2O acts as a nucleophile. The sulfur in H2S attacks the electrophilic carbonyl carbon of acetyl chloride. And for the final step. Mechanism. The sulfur of H2S attacks the carbonyl carbon of CH3COCl, forming a tetrahedral intermediate. The chloride ion then departs as the leaving group. This generates CH3C is equal to O, thioacetic acid, with HCl as a byproduct. Evaluate options. Option A involves addition rather than substitution and breaks aromaticity of the carbonyl, not the product of nucleophilic acyl substitution. Option B CH3C is equal to O is the direct product of nucleophilic acyl substitution where Cl is replaced by Sh. This is correct. Option C CH3C is equal to S. Cl would require replacement of the oxygen, not chlorine. H2S is not an oxidant and does not exchange O for S under these conditions. Option D. The anhydride type product would require two equivalents of acyl chloride reacting with one sulfide dianion. This is not the major product under simple H2S conditions. Conclusion. The nucleophilic acyl substitution of H2S with acetyl chloride replaces Cl with Sh, giving thioacetic acid, CH3COH, as the major product. Therefore, the correct answer is B. Therefore, the correct answer is option B.